Hi everyone. So let's start now. Now we will study correlated subqueries, or you can say correlated nested queries. Okay. So Sagun, Sagun, this class, I think it will go for 2 hours. Okay. Now let's see this correlated subqueries, or I can say correlated nested queries. So far, what we have seen. So far we have seen simple subqueries, right? Yes or no? Simple subqueries. In the simple subqueries, you can very easily see that the subquery does not depend on the outer query. Okay, that I can say the subquery, the inner subquery is completely independent of the outer query, right? And how do we conceptually evaluate this? Okay, so it is evaluated once. Okay, and you can notice the simple subquery you can evaluate one time, and then you can use the result again and again. So this is your simple subquery. Now in general, what happens in general? Okay, the inner subquery, it can use the result of outer subquery. Okay, it can be dependent on the outer subquery. It can happen. Okay, so the inner subquery can use the result of outer subquery. This type of subquery are called correlated subquery. Okay, so this type of subquery, what we call them? We call them correlated subquery. When, for example, look at this subquery. Okay, just look at this subquery, right? This is your whole query, right? Yes or no? Correct. So look at this subquery. I am giving you a subquery, and you look at this. Okay, so you look at this subquery. Now this is your complete query, right? I can say this is your main query. Yes or no? I can say this is your main query. So maybe I can call it main query, or I can say outer query. This is your main query. Okay, okay, and you can notice this is a subquery. You are using another query inside this. This is a subquery. Correct, this is a subquery. So this is your subquery. Tell me one thing. The subquery, is it dependent on the outer query? Look at the subquery. Can you notice this is dependent on the outer query? This is dependent on the outer query. Yes or no? This is dependent on outer query. How? Why? Because you can notice this subquery. If I remove the outer query, does it make sense? If I remove the outer query, does it make sense? Does it make sense? It is not making sense, because you have this r dot b. From the outer query, you are using this r dot b, right? From the outer query, you are using this r dot b. Okay, so from this outer query, you are using this r dot b. Okay, so this subquery, it is using the attributes of the outer query, right? It is using the attributes of the outer query. So you can very easily say that this is correlated subquery. This subquery is a correlated subquery. Is this clear to everyone? What is a correlated subquery? Is this clear? So correlated subquery simply means that it is dependent on the outer query. Correlated means it is dependent on the outer query. It will depend on the outer query. Okay. Now, how to evaluate this type of query? When you have the correlated subquery, though, so how to evaluate this? Let's assume this is your main query. Okay, this is your main query, and you have a relation r here. Maybe you have a relation r here, and this is your subquery. In this you have relation s. Okay, and so you can notice here you have a relation r. So this is a relation. You can note this is a relation r, and this is subquery, and let's assume this is relation s. Okay, or what you can do, or you can simply say that this is your query q. Okay, this is your relation r, and this is your query q. This is your subquery. This is your subquery q. And let's assume this is correlated, means it is dependent on the outer query. Let's assume this is correlated. Let's assume, so means it depends on the outer query. Okay, some attribute of r you are using here. Here you are using some attribute of r. Okay, some attribute of r you are using, maybe r dot a. Okay, some attribute of r you are using here. So this is your correlated subquery. Now, how to conceptually evaluate it? This is called conceptual evaluation. Again, this is called conceptual evaluation. So how to conceptually evaluate this? So the concept to conceptually evaluate. Remember. Can I compute it once and be free? Just think about it. Can I compute it once and be free? Can I compute it once? Can I compute it fast? My point is very simple. Can I compute it fast? I cannot compute without this. Without this, I cannot compute. Without this, I cannot compute. So can I go bottom up? Can I go bottom up? Can I go bottom up? No, I cannot go. I cannot go bottom up. Okay. Here, what will happen? For every r dot a, for every tuple, what you will do? For every tuple of r, for every tuple of r, for every tuple of r, you will replace this r dot a, then you will compute. For every tuple, for t1, this t1 dot a you will put here, then you will compute. Okay, and then you will do. So basically what will happen? Conceptual evaluation means what will happen? This will happen for every. Okay, so for every tuple of r, for every tuple of r. Okay, so remember this. I'm assuming that you are using this in the where clause. I'm assuming that you are using this in the where clause. In the where clause, you are using this subquery. This subquery you are using in the where clause. Okay, so where clause will go tuple by tuple, correct? It will go tuple by tuple. The where clause will go tuple by tuple. So if you use this in the where clause, then the where clause will go tuple by tuple. So I can say that for every tuple of r, what will happen? What will happen? You will compute q. For every tuple of r, you will compute q. Okay, is this clear? For every tuple one by one, for every tuple of r, one by one, you will compute q. Remember. You can also put this query, this subquery in the having clause. You can also put this subquery in the having clause. You can also put this subquery in the having clause. The having clause will go tuple by tuple or group by group. The having clause will go tuple by tuple or group by group. So it will go group by group. Okay, it will go group by group. So for every group, you will evaluate this. So for every group of R, you will compute Q. Is this clear to everyone? Let me know. Okay, so this is how you compute this. Okay, with example, you will understand. Let's take this example. With example, you will understand, don't worry. This correlated subquery, this is a very easy topic. Okay, so just take your copy pen so that it becomes more easy. Just take your copy pen so that it will become more easy. Okay, now let's see. First of all, look at this question and you tell me. The first thing is to decide, is it correlated or what? First to decide, is it correlated? This is the first step. What the step one? The step one. What the step one? Okay, is it correlated or not? Is the subquery correlated or simple? Step one, right? So remember, this is your step one. What is the step one? The step one is a subquery correlated or simple? Look at this subquery. Look at this subquery. It is correlated. It is a correlate. It is correlated. Okay, so it is definitely correlate. Okay, so this is correlated. This is your step one. Step one is done. Step one is done. Step one is done. Now this is correlated. So now what we will do? Now what we will do? The flow will be like this. The flow will be like this. See, the flow will be like this. Okay, you will start here for every tuple. For every tuple, you will do this. You will use the result. Okay, for every tuple, this is what you are going to do. For every tuple of R. Every tuple of R one by one. So first you take this tuple. Okay, so what will happen here? So remember what will happen, because this is correlated. So for every tuple of, and this you are using in the where clause or not? This you are using in the where clause. So I can say for every tuple of R, for every tuple of R, one by one, execute this small q. Let's call it small q. Compute small q. compute small q. Okay, this is the step. See, I am going very step by step. I am going in a step by step manner. So you just understand every concept clearly. Okay, so every tuple you need to check. Okay, so let's check this tuple. Okay, so first I will check this tuple. Check tuple. What I will check? I will check this tuple 1, 2. Is this clear? I will check this tuple 1, 2. I will check this tuple of R. This tuple of R. You check this. Check this. Does it satisfy? Check this. Check it. Does it satisfy? This tuple. This tuple, does it satisfy? So when you are checking this tuple, then what will be R dot B? When you are checking this tuple, what will be R dot B? When you are checking this tuple, what will be R dot B? So this R dot B, what this will be? This R dot B, this will be equal to 2. Okay, this R dot B you can replace with the 2. This will be 2. So you can just replace this with the 2. Okay, you can replace this with the 2. Now you evaluate this. Now you evaluate this. Okay, so this is your tuple. So you can clearly see R dot B is equal to 2. Now you compute Q. Now you compute this Q. So tell me what your computation of Q will happen. Now you compute this Q. What your Q will give you? So this is giving you select count star from S where R dot B equal to S dot B. Count star. Select count star where R dot B equal to S dot B. Where R dot B equal to S dot B. So this is gone. This is gone. Okay. So only one tuple will be there. So what will be the output? The output will be count star. The output will be count star 1. Output will be this or not? Yes or no? Output will be count star 1. Okay. Now. Is this condition satisfied? Is this condition satisfied? Check it. Check it. Is this condition satisfied? Is this condition satisfied? The value of A. Value of A is 1. Value of A is 1. Is 1 greater than 1? Is 1 greater than 1? So the answer is false. Okay. So you can notice this is a false. So that is the reason I can say this tuple will not be in the output. Yes or no? In the output, this tuple will not be there. Agree or not? Okay. So this tuple will not be in the output. So I can say in the output, okay, 1, 2 not there. 1, 2 not in output. So did you understand? See, very step by step I have gone. Did you understand this? Tell me, did you understand this? Very simple. See, this is very simple. What we have done, step by step we are going. Okay, very simple. Now tell me about the next tuple. It will check one by one. Now check this tuple. Check the next tuple, that is 3, 4. Check this tuple 3, 4. Check this tuple 3, 4. Okay, this tuple check. This tuple, will it check? Now you check it. Check it, check it, check it. Does it satisfy this condition? This condition, is it satisfied? Okay, first of all, for this, what will be R dot B? R dot B is equal to 4. So this R dot B is equal to 4. Okay, so here what will be count star? What this query Q will give you? See, step by step, what this query Q will give you? What this query Q will give you? It will give you count star. What this query Q will give you? It will give you count star. Okay, where R dot B equal to S dot B. So this is gone where R dot B equal to S dot B. So this will be 2. There are 2 tuples. So the count star will be 2. So can I say the value of A? This is value of A. Can I say value of A is greater than 2? Can I say 3 is greater than 2? Can I say 3 is greater than 2? Yes. So this tuple will satisfy. So here I can say this tuple will be in the output. So 3, 4 in output. So this tuple will be in the output. Isn't it simple? This correlated subquery. Correlated subquery. This is very simple, right? Yes or no? Okay. See, step by step I am going. So it is taking time. But it will not take time. You can notice. Once you understand, once you do some practice, it will not take time. This is easy. Okay, let's see the next. Okay, what I am going to do now? Now the last row is remaining. Now the last row is remaining. So now you will do this where close. It will go tuple by tuple. Take the next tuple, that is 5, 6. Take the next tuple, that is 5,6. Check it. Take the next tuple and check it. Will it satisfy this condition? So here you can notice this was true. Okay, so will it satisfy this condition? So here you can notice r dot b is equal to 6. So this r dot b, this is equal to 6. Okay, what this query will give you? Look at this query. What this query will give you? This will give you count star. Is this empty? Can I say this is empty set? Tell me. Can I say this will give you empty set? Can I say this will give you empty set? Okay. Can I say this will give you empty set? Can I say this will give you empty set? Can I say this will give you empty set? Will this query give you empty set? Is this empty set? Is this empty set? Count star. Okay, this is the attribute. Is this empty set? Is this empty set? Is this empty set? Is this empty set? No. This is not empty set. So why are you saying this will give you empty set? Why are you saying this will give you empty set? Why are you saying this will give you empty set? So this will not give you empty set. This will give you 0. This is not empty set. This is not empty set. This is not empty set. This is a value which is 0. Is this clear to everyone? Ekta, Priya, Akash, Yuvraj. So this is not an empty set. Okay. So now, anyway, so this 0 you will get. And this 5, this is A. Can I say A is greater than 0? This 5 is greater than 0. Yeah, this is true. So finally, I can say this tuple 5,6 in output. 5,6 in the output. Is this clear? So finally, what has happened? What is your final output? What is your final output? Your final output is AB. Your final output is 3, 4, 5, 6. This is your final output. 2 tuples. 2 tuples. This is your final output. Clear or not? Clear or not? Okay. This is your final output. So like this you can do. So this is your correlated queries. Okay. So can you notice? Can you notice? This is the conceptual evaluation. This is the conceptual evaluation that for every tuple, we will compute. We will recompute. For every tuple, we are recomputing. Okay. Now let's see. Before we see more questions, we will see a lot of questions. We will see. But before that, let's see one more keyword, that is exists and not exists. This is a common mistake that students use, exist. Okay. Is this the keyword? Which is the keyword? Is this the keyword or is this the keyword? Is this the keyword or is this the keyword? You know, this is the keyword. This is the SQL keyword. Okay. This is the SQL keyword. This is not the SQL keyword. So this is the SQL keyword. Exists and not exists. Okay. What this talks about? What do you think? What this talks about? Exists. What this talks about? This talks about existence only. Yes or no? Existence. This talks about existence of tuple. Okay. This talks about existence of tuple. Existence of tuple. So the syntax is very clear. The syntax is very clear. It talks about existence of tuple. So the syntax is very clear. See, the syntax is this: exists, and here you have a subquery, and here you have a subquery, and here you have a subquery. Here there is nothing. Here there is nothing. Okay, is this clear? Here there is nothing. On LHS there is nothing. So it only talks about exists subquery. This will be true. When this will be true? This will be true if there exists a tuple here. This will be true if and only if there exists a tuple here. If and only if this is subquery is non-empty. If and only if the subquery result is non-empty. Is this clear? Result is non-empty. Means there exists a tuple. It talks about the existence of tuple. Is this clear to everyone? This is the syntax. And when this will be true, not exists. When this will be true, it will be true if the result is empty. If tuple does not exist. If tuple does not exist. If tuple does not exist. So this is the syntax. Please understand the difference between syntax. What is the difference between syntax of exists What is the difference of syntax of exist and syntax of in? What is the difference? What is the difference? Here you have two, okay, two things. Here you have a tuple. Here you have a tuple in subquery, correct? Do you agree? So here you have two things, tuple in subquery. So I can say this is binary. Can I call it binary? Can I call it binary operator? You have two things. This is a binary operator. And this exists. It has only one thing, that is exists, okay, subquery. Exists subquery. So this is unary. Only one operand is there. Only one operand is there. So you can notice here you only have one operand. Is this clear? Okay. So very simple idea. Okay. So remember here you have only one kernel. So this will be true if there exists a tuple here. This will be true if there exists a tuple here. Okay. And this not exist will true if there does not exist a tuple here. So this checks about the emptiness. Can I say this exist and not exist? They check the emptiness of relation. They check emptiness of subquery. They check emptiness of subquery. Very simple, isn't it? Okay, so very simple. Now, so this not exist R and this exist R. Correct. Okay. Now let's move on. Let's see this query. One by one, let's see some examples. Let's see this query. First of all, what is the step one? What is the step one? What is the step one? Is this correlated or not? Yes or no? The step one, is this correlated subquery? Look at this subquery and tell me, is this correlated or not correlated? Look at this subquery. Is this correlated? Who is telling you that this is correlated? Who is telling you? Who is telling you this is correlated? Whose B is this? This B is in S. Can I say this B is in S? Can I say this B is in S? No, this B is not in S. In S we don't have B. In S we don't have B. Okay, so automatically this B is from R. Okay, so you can notice this C is from here and the B is from here. The B is from here. Okay, so finally I can say this is correlated. Agree? This is correlated. This subquery is a correlated subquery. This subquery depends on the outer query. So this is the first thing. This is the step one. This is a correlated subquery. Okay, and this is your exist. So tell me, what the step after this? You know this is correlated. Now what you will do? And this is in the where clause. And this is in the where clause. So tuple by tuple you will check. So you will check tuple by tuple. Okay, so let's check for the first tuple. What you will do? Okay, so tell me for this tuple. Check, okay, check tuple this, check this. Check it. Check this tuple. For this, is this true? Is this true or false? So tuple by tuple you will give. You will go tuple by tuple. So you take tuple 1, 2. Okay, you take tuple from R. So you take tuple 1, 2. In this tuple, what is the value of B? The value of B is 2. So the value of B you will put 2. Okay. Now what this query Q will give you? What this query Q will give you? Okay, I am only interested in empty or not empty. I am not interested in yes or no. I am only interested in the result is empty or not empty. I am only interested in the result is empty or not empty. So tell me, from S, where B is less than C. From S, where B is less than C, you select those. Okay, so this is definitely not empty, right? This is definitely not empty. This is definitely not empty. What will happen here? This actually you will get. This is definitely not empty. Actually, your output will be this. Okay, wherever C is greater than 2. So your output actually will be this. So definitely this is not empty. Right? So because this is not empty, so I can say exist a row. Okay, so I can say exist a row. So this becomes true. Exist a row. So this becomes true. So who will come in the output? So who will come in the output? So this 1, 2 will come in the output. So this 1, 2 will come in the output. Okay, so this 1, 2 is going to come in the output. Simple. Is this clear? Simple or not? This concept is simple, right? Yes or no? The same thing we are doing. The same thing we are doing. Now you tell me back to back quickly. Okay, I'm not going to take new page for every tuple. I will not take new page for every tuple. You tell me in this page, you tell me about this 3, 4. What about this 3, 4? Okay, when you take this tuple 3, 4, when you take this tuple 3, 4, then the value of b is 4. Then the value of b will be 4. Okay. Now in this query, will this give you, okay, so those tuples where c is greater than 4, definitely this is non-empty. I am only interested in empty or non-empty. My only interest is empty or not empty. Yes or no? This is my only interest. Is this empty or not empty? So this is not empty. So because this is not empty, so this tuple, what this tuple will do? This tuple, for this tuple, this is true, right? Exist. Because this is non-empty, so this exist will become true. So who will come in the output? So 3, 4 will come in the output. This will come in the output. Agree or not? Isn't it simple? Okay. Very step by step I'm going, nothing else. So this is your query. What about this next 5, 6? What about this next 5, 6? For 5, 6, what you can do? Again, for 5, 6 also, this will come in the output, right? Okay, so similarly, this 5, 6 will come in the output. This 5, 6 will come in the output, because again, the result will be not empty. But you check this 7, 8. Let's check 7, 8. Okay, let's check 7, 8. You take this tuple 7, 8. The value of b will be 8. The value of b will be 8. Okay. So those tuples, I want those tuples. I want those tuples where c is greater than 8. I want those tuples where c is greater than 8. I want those tuples where c is greater than 8. This is not, this is empty, right? Yes or no? So this is empty. This is empty. There is no tuple, no tuple, no tuple. Exist. Tuple does not exist. Tuple does not exist. So this is false. Okay, so this is not in output, right? Okay, so this is not in output. This is not in output. So finally, your answer is what? Finally, your answer is what? For the previous question, the answer is how many tuples? So the final answer for the previous question, in the output, you will have 3 tuples of a comma b. You will have 3 tuples of a comma b. Okay, those will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This will be your answer. There will be 3 tuples in the output. So this correlated subquery, isn't it simple? This correlated subquery. Okay. What meme comes to your mind? This correlated, what is happening in this correlated subquery? In this correlated, what is the evaluation? In the correlated, when you have correlated nested query, then what is the evaluation? What is the conceptual evaluation? What is the conceptual evaluation? This is the conceptual evaluation. Take one tuple from here. You send that tuple here to check. Agree or not? Okay. So what you do? This is your queue. Now you take tuple from here. Okay. When this is in the where clause, you take tuple from here. You send it here in this area. You take one tuple from here. You send it in this area. You take another tuple. You send it in this area. You take another tuple. You send it in this area. Okay. Correct or not? Okay. So for every tuple, you do this. Every tuple. So what it will do? It will take tuple by tuple. It will take tuple by tuple. It will take tuple by tuple. Or who will take actually? I can say this where. This where will take tuple by tuple. Tuple by tuple of R. This tuple by tuple of R. And what you do? This tuple by tuple of R. And you send it here. You send it here. Okay. You compute. And then you do the calculation. So you can notice this is step 1. This is step 2. This is step 3. After computing, you check, is this true or not? This is step 4. Is this satisfied or not? Okay, this is the step 4. So like this. So this is the meme you can see. Okay. So now you will not forget the nested query. Okay. So for every query, what outer query is saying? For every row, what outer query is saying? Okay. Yes or no? Isn't it? So tell me, is this clear? The outer query, for every query, what this is saying? The outer query for every row, the outer query is saying, go and ask. Okay. And what is the simple? When you have simple subquery, then what happens without correlation? When you have simple subquery without correlation, then मैं पहली और आखिरी बार आया हूं. Yes or no? Okay. Okay, only one time. Yes or no? Only one time. Just execute once. Okay, once and for all. Once and for all, that's it. Now let's see this. So let's see this question. Tell me the answer for this question. Quickly tell me the answer for this question. A question on your screen. How many tuples in the output? How many tuples in the output? Tell me. How many tuples in the output? How many tuples in the output? Number of tuples in the output. So, okay, just find out number of tuples in output. What is the number of tuples in the output? The same question. I am just changing it to count star. The same question I am just changing it to count star. Why? You don't even have to calculate it. Array, you don't even have to calculate it. Array, you don't even have to run it. You don't even have to run it. Why? Why? Tell me why. Can it ever give you empty set? Can it ever give you empty set? Can count star ever give you empty set? Like even if you have empty relation, even if your relation is empty, then what is count star? What is count star of R? What is count star of R? That also will be 0. That also will be non-empty. That also will be non-empty. Is this clear? Even if your relation is empty, still the count star will never give you empty. Agree. It will give you 0 and it is not empty. Whatever aggregate function I use, whatever aggregate function I use, what is sum? Like, okay, if you have attribute A, what is sum of A? What is sum of A? What is sum of A? That will be null. Again, this is not empty. Again, this is not empty. If I use aggregate function, okay, any aggregate function I use, whatever aggregate function I use, what will happen? Whatever aggregate function I have, either null you will get or you will get 0, but it will be non-empty. Is this clear to everyone? Is this clear to everyone? You can never get empty, right? Array, even if your relation is empty, even if no one satisfies, you will get 0, which is not empty. Okay, even if no one satisfied, you will get sum of A equal to none, which is not empty. Whatever aggregate function you take, you will either get null or 0. You will get at least one tuple. Yes or no? There exists a tuple. Correct. There exists a tuple. So this is non-empty. So even you don't even have to check it. This count star will always give you non-empty. This count star will always give you non-empty. See. For this 7, 8, what will happen? For this 7, 8, what will happen for this 7, 8? When you take this 7, 8 tuple, the value of B is equal to 8. Okay. In this situation, what this output you will get? What is the output that you will get in this situation? The output you will get is count star. Okay, output you will get is non-empty. This is non-empty or not? इसको आप नॉन एम्प्टी नहीं समझते क्या? ओके, दिस इज नॉन एम्प्टी. Yes or no? One tuple exists. Don't say zero tuple exists. One tuple exists with the value 0. One tuple exists with the value 0. Okay, one tuple exists with the value 0. So this will become true or not? This will become true or not? So this also will go in the output. Is this clear? See, this is a tricky point. Many students I have seen this question. Okay, I have seen many students. What they do? They do like this. Oh, okay. Let's calculate. So for 7, 8, this will become 8. So let's calculate. So what will happen? Okay, no one satisfies. Yeah, now okay, no one satisfied. No one satisfied. There is no value of C which is greater than 8. So this is empty. Okay, this is empty. So this is empty. So this is false. So this is false. So this will not be in the output. Yes or no? This is what many students do. I know. This is the thought process. Is this clear? Okay, this is the thought process of many students. I have seen this. Is this clear to everyone? This is the thought process. I have seen this. What they think like this. Okay, B equal to 8. C greater than 8. There is no C greater than 8. Oh, I'm genius. So there is no C greater than 8, right? Okay, so I got 2 marks because there is no C greater than 8. So the result is empty. So this will become false. I got 2 marks. Okay, I will go to IIT. Then, okay, then next day they will prepare for the GATE exam again. Okay, so you can notice. So is this clear to everyone? So everything matters. Yes or no? Everything matters. So this is count star. So, and in the previous question, what was there? In the previous question, what was there? In the previous question, what was there? Tell me in the previous question, what was there? In the previous question, we had only star. So there you will get empty tuple. Are you getting my point? In the previous question, we did not have aggregate function. But here we have aggregate function. So this is wrong, right? Yes or no? So this when you say this empty, so this is a wrong. Okay, why this is wrong? Because count star will give you 0. Okay, and you are, there is 0. So this is non-empty. So this is non-empty because there is 0. Now 0 will be thinking, what are you doing? Bhai, kya kar raha tu? Yes or no? This 0 will be thinking, what are you doing? You are not considering me as a, yes or no? You are not considering me as a tuple. Consider me as a tuple. This 0 is saying, consider me as a tuple. I am one tuple. Okay, I am one tuple. I am a tuple. Yes or no? I am one tuple. So if you say empty, then that will be wrong. Okay, so I hope this point is clear. So now I think now you will keep this in the mind. Yes or no? Now you will not make this mistake. Now let's see this question. Tell me the answer for this one. Okay, so this question we have done. Sorry, not exist. Okay, this is not exist. So tell me for this question, what is going to be the answer? Not exist, for which you will get empty. And this is here star. Remember, this is not aggregate function. The same question, but now this will satisfy. Okay, for this will become true. For this it will become true. So your output will be A, B. Only one tuple you will get in the output. Okay, one tuple. Only one tuple you will get in the output. Okay, because only for 7, 8, this not exist will be true. Only for 7, 8. For the remaining people, it will become false. Okay, because you have not exist. And the same question with the count star. Not exist. With the count star. This will always exist. Yes or no? This will always be non-empty. This will always be non-empty. This is always going to be non-empty. Okay, so that is the reason. Finally, I can say, so this will never satisfy. Yes or no? So this will never satisfy. So I can say your output will be what? So your output will be empty set. Your output will be empty set. Your output will be like this. Okay, your output is going to be empty set. Is this clear? So this is your question. Tell me the answer for this question quickly. You are expert of correlated queries. Now I know you are expert of correlated queries. Here you are taking the tuples. Here you are taking tuples that will satisfy. This is not aggregate operation. This is not aggregate operation. And this is correlated. Yes or no? So this is correlated because there is, so this is a from R, right? Yes or no? This is from R. So this is correlated. So this is the first thing you need to notice, that this is a correlated subquery. This is the correlated subquery. Okay, so what you will do for every tuple, you will check. Okay, for every tuple, what you are going to check? You are going to check from S, this R for R. Okay, for this B value, the number of tuples, the number of this is greater than C. This is invalid, right? Yes or no? This is invalid. This query is actually invalid. Correct? This query is actually invalid because this is I can say this will have many tuples. This can have many tuples. There is no guarantee that it will have single tuple. You don't have clean, you don't have that aggregate function here. So can have multiple tuples, many tuples, can have many tuples, right? Okay. So basically you don't have aggregate function. So you cannot do this. So this is invalid. This query, forget about the output. This is invalid. Forget about the output. This is invalid query. This query is invalid. Forget about the output. This query is invalid nonsense query. Okay. Let's move on. So remember, this is invalid query. Forget about the output. This is invalid query. What about this question? This is valid query. Okay. This is valid query. See, every type of question I have taken. Okay. These slides making slides like this takes time. Yes or no? Like these are the questions from standard resources. I'm not creating, like I'm not sitting and creating these things. So these things are the questions from standard resources. Okay, now tell me here. So tell me here, where B is less than C. Now this is fine. This is a valid query. This is a valid query. You will get a single tuple. You will get a single tuple in the output. So this is a valid query. And this is correlated. This is correlated. So this query, if you notice, this is correlated. Okay, so what is your output? So for every tuple you will check. Okay, so what should happen? The number of C value, which is greater than B value, you can notice, sorry, the number of tuples with the C value greater than B value must be at least 2. Yes or no? Yes or no? Yes or no? Read the query and you understand the query. What is the output of this query? Read the query and you understand the query. The output is this. Those tuples of R. Okay. The output will be this. The output will be those tuples of R. Okay. Those tuples of R for which such that. Okay. Those tuples of R such that number of tuples in S with C value greater than B value is at least 2. Is at least 2. Agree or not? Tell me yes or no. Okay, so number of tuples. So those tuples of R you will get, for which number of tuples in S with the C value greater than B value is at least 2. What about this? The C, yeah, so this will satisfy, right? This will satisfy. What about this one? This will satisfy. What about this next one? Number of C value which is greater than B value. So this will fail, right? Yes or no? This will fail. This tuple will fail. And similarly, this tuple will fail. This tuple will fail. Clear? Yes or no? Because You can notice for this tuple, what will happen? When you put this tuple 7,8, when you put this tuple 7,8, then what will happen? If you put 7,8, so this B value will be 8. So count star where C is greater than 8, that will be 0. So this count star will give you 0. Is 0 greater than equal to 2? Is 0 greater than equal to 2? That is false. 0 greater than equal to 2. This is a false. So finally, I can say this tuple will not be in the output. Yes or no? Not in output. So very simple question, and your answer will be number of tuples will be what? In the output, number of tuples will be what? In the output, you will have these tuples AB 1, 2, 3, 4. 2 tuples will be in the output. Okay, 2 tuples. So like this you can do. Okay, like this very easily you can do. So tell me the answer for this question. Find the names of sellers who reserved boat number 103. Find the names of sellers who reserved boat number 103. Can you write a correlated query? Can you write a correlated query? Remember the meme. Remember the meme. So what you need to do? Write a correlated query. So what you will do? Write a correlated query. Write a correlated query. And whenever you are writing a correlated query, remember this meme. What the seller table will do. Okay, what the seller table will do, you want to write a correlated query. You want to write a correlated query. This is your seller table. You want names. This is your seller table. You want names. So those names you want, where? So what the seller table will do, it will send the SID. It will send the SID to the inner query, right? Agree or not? It will send the SID to the inner query. This seller table, it will do what the seller table will do. It will check that there should exist. It will check that there should exist a tuple. There should exist a tuple in the reserve table. In the reserve table, there should exist a tuple. Remember, you can count, or sorry, you can find the number of tuples. Select star. Okay, select star from reserves. From reserves. Okay, in the reserve table, you will find where what happens, where BID should be equal to 103 and R.SID should be equal to what? S.SID, isn't it? Yes or no? This what it will give you? See what the seller table will do. Tell me what the seller table will do. This seller table will send the SID. Yes or no? See this meme. This seller table, it will send the seller.sid. Ja pooch kya? Yes or no? To the reserve table. To the reserve table. Yes or no? Is this clear to everyone? So this seller table will send the seller.sid to the reserve table. Ja pooch kya? Okay? Yes or no? So to the reserve table, this will go and it will check. So this is the same idea. Whenever you write a correlated query, remember the name. Remember the meme, sorry. Whenever you write a, okay, remember the meme. See, memes are so powerful, yes or no? Can you notice? Now in the future, I can guarantee that you will solve the correlated query questions very easily. You can write the correlated queries very easily if you understand this meme. If you understand this meme, if you remember this meme, basically send, okay, just send inside. So what this seller table will do, you want S names. So what you will do, very simple, you will send the S.SID. You will send the S.SID inside. You will check the tuples where, okay, you will check the tuples where BID must be 103 and R.SID should be equal to S.SID. Okay, so this should exist. This should exist. This is your query. That's it. So for example, what actually on this example, what will happen? See this, on this example, what will happen? This seller table, what it will do? The seller table, what it will do? For this row, it will send this 20. Yes or no? This 20 is going. This 20 is going to the reserve table. See, this 20 is going to the reserve table. This 20 is going to the reserve table. Okay, yes or no? Correct? Send SID 20. Send SID 22 to the reserve table. In the reserve table, what you will do? You will find where for this same SID are you getting 103? Are you getting? Is there any row? Is there any row where you have 22, 103? Yes. So there exists a row. There exists a row. There exists a row. So there exists a row. So you can notice there exists true, right? Okay, exists a row. So this exists becomes true. This exists becomes true. Okay, once this exists becomes true, what this SID will do? Once this exists becomes true, what this SID will do? Now it will go back. Okay, yes or no? Now once this becomes true, so this is your step 1. This is your step 2. And what is the step 3? The step 3, now this 22 will go back to the seller table. Okay, now this 22 is going back to the seller table. Okay, now you can notice 22 going back to seller table. Going back to seller table. And okay, to tell what? That I satisfied. Yes or no? That I satisfied. Then finally the seller table, what it will do? This S name will go in the output. Okay, this S name. So finally this S name will go in the output. So this is your step number. So this was step number 3, right? Okay, this was step number 3. This was step number 3. Like this, you can understand this. This was step number 3. This is step number 4. And now it will go in the output. That is your step number 5. So very easily you can understand. Yes or no? Correct or not? Okay. So is this understood? Tell me. So you will write the query like this. You will write the query like this. The seller table. It will send the SID inside and it will check. Okay. Is this clear? I had done select SID. That is also fine. Array, that is also fine. Star is not mandatory. You can also do SID. That is also fine. But if you do SID, okay, whose SID it will be considered? Whose SID it will be considered? It will be considered whose SID? It will be considered SID of R, closest. It will be considered SID of closest. If you write SID directly, it will be considered SID of R. That is also fine. This query is also correct. This query is also correct. But this query is not correct. But the problem will happen if you do count star. Yes or no? Problem will happen if you do counting. Now the problem will happen. Now what will happen? In this query, what will happen? What this query will give? What this query will give? This query, what this query will give? The problem will happen because this is always non-empty. Because this is always non-empty. This is always non-empty. Now what this query will do? Now this query will do all seller names. Yes or no? All seller names you will get in the output. Now you will get all seller names in the output. Okay? You will get all the seller names in the output. Clear? In a very step-by-step manner, I have told you all these things. Is this understood? Tell me. How to write correlated query? Writing correlated query, did you understand? This meme is going to help you a lot. It helps me a lot because I know. Okay, like whenever I write a correlated query, in my mind it comes, okay, that I will send it. Like it's like sending a messenger. Yes or no? It's like sending a messenger. You are sending the messenger that, okay, send the messenger. The messenger will do, okay, inside whatever it will do. So this correlated query, this meme will help you whenever you want to write a correlated query. Tell me about this answer for this question. I want names of sellers who have not reserved bot 103. Who have not reserved bot 103. So not exist. Yes or no? So not exist. Just do not exist. So not exist will work. So then in the same question, In the same question, if I put not exist, in the same question, if I put not exist, like there is no not exist, then automatically I will get who have not reserved. Then I will automatically get who have not reserved a bot number 103. So I can just put not exist. Okay. So let's see the next keyword, that is unique, not unique. The name itself is telling you what unique means. The name itself is telling you what unique means. Tell me what unique means. What do you think? What do you think what unique means? This is the syntax of unique. First of all, this is the syntax of unique, that you have unique. Okay, and here you have a subquery. And here you have a subquery. Okay, so this will be true. This unique will be true if and only if every tuple is unique. Yes, 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 yes. Okay, this unique means this unique will be true if and only if in this subquery every tuple is unique. Okay, no duplicates in the, if and only if no duplicates in the result of subquery. Is this clear? In the result of a subquery, in the result of subquery, there are no duplicates. We don't have any duplicates, then it will give you this. And what about this not unique? Okay, this will be true. This not unique will be true if and only if there exists some duplicate in the result of the query. Agree or not? So this is a very simple word, unique. Now let's see this all, any, some. So first of all, remember in the SQL you have these keywords. First of all, in SQL, this keyword and this keyword both are same. In SQL, this keyword, which keyword? This keyword sum. This keyword is exactly same as this keyword any. First of all, is this clear? This keyword is also there. This keyword is also there. Both are the keywords. Both are the keywords. Both are same. Okay. So any means sum here. And there is another keyword, that is all. Okay. So very simple, that if I want to say, so for example, in which situation this, what is the syntax of any? This is the syntax of all, that it's like this. Is it less than, for example, some comparison, is this less than all, and here subquery, okay, like this type of situation. Is this less than, is something, here you have something, is this like some value, some tuple, okay, is this less than all of them? Okay, so this type of, this is the syntax. Is this clear? This is the syntax. This is the syntax. So notice, this is the syntax. When this will be true, this is the syntax. When this will be true, this will be true if this is less than or equal to, if this is less than or equal to all the values here. Yes or no? If this is less than equal to all the values in this, so I can say this will be true. I can say this will be true if and only if S is less than equal to every value in the result of subquery. Every value, every tuple in the result of subquery. In the result of subquery. This is like a for all quantifier. Okay, this is like for all quantifier. This is like your for all quantifier. Okay, it is similar to that. It is like for all quantifier. So if subquery is empty, if your subquery is empty, then what will happen? If this subquery gives you empty result, if this subquery gives you empty result, then what will happen? If this gives you empty set, then this will be true, right? Because this is like a for all quantifier. So when you have empty set, this for all quantifier automatically becomes true. So if empty set, then you can notice this condition is satisfied. Yes or no? Then this all is true, right? Yes or no? If you have empty set here, like if you have empty set, and I say 40, is 40 less than this empty set? Is 40, here I put 40, let's assume 40, is 40 less than this, and let's assume here you have empty set. then this all will be true. Is this clear? Then this all will be true. Similarly, you have any. What is any? Any is same as sum. I told you any is the same as sum. So this is like existential quantifier. Okay, so this will be true if and only if s is less than some value in the result of the query. Yes or no? S is less than equal to some value in the result of the query. Again, the same question. Again, the same question. If this is empty, here you have any. This is like existential quantifier, and you have any. If you have empty set, then what you will say? This any, this sum will be false. Right? This we have already seen in the discrete mathematics, that this existential quantifier for empty set, this will be false. So these are the syntax. Is the syntax clear to everyone? Or remember, here you can put any operator. Here you can put any operator. This operator can be any comparison operator. This operator can be any comparison operation. This can be any comparison operator. Like you can put equal, you can put not equal, you can put less than, you can put less than equal to. Okay, you can put a less than equal to. You can put greater than equal to. So these things you can put. So any comparison operator you can put. You can put greater than. So any comparison operator you can put. Is this clear? Whatever comparison operator, the same meaning. The meaning is same. So whatever comparison operator you want, you can put. This is the meaning. Is this clear to everyone? Like, let's see this question. What is the answer for this question? Find sellers whose rating is better than some seller called Horatio. Some seller called Horatio. So from the seller table, I want names. Yes or no? Correct? From the seller tables, I want names. I want as name. Where? What should happen? What should happen where? Rating. I can call it s dot rating. Yes or no? Where s dot rating? So I want s dot name. So I can say where s dot rating should be. This is better than some seller called Horatio. Yes or no? Which is better than some seller called Horatio. So this rating should be greater than. This rating should be greater than what? Correct? Better than. This is greater than what? This is greater than any. This is greater than any rating here. This is greater than any rating here. So here also you will select the rating. Here also you will select the rating. Let's call it S1. So here also, here you can select the rating. Okay. So any of these rating where the person is Horatio. So you will find where the person name, S name is Horatio. Yes or no? Where the person name is this. From sellers. Is this clear? This is your query. Isn't it simple? Tell me. You want rating. Sorry, you want those sellers. You want those sellers whose rating is greater than. Just find all the sellers of name Horatio. Find all the sellers. So find the rating of all the sellers whose name is Horatio. Okay. So where name is Horatio. So where this is the name, you find those ratings. You find those ratings where this is the name. Okay. Then you are looking for those sellers whose rating is greater than any of these values. Whose rating is greater than any of these values. This is your answer. Okay. Very simple. So this is a simple question, and like this you can do. Tell me about this one. Which is better than every? Which is better than every? Just replace that with all. Replace that with all. So in the same query, this is your query. In the same query, what you do? You replace that with all. So in the same query, this any you replace with all, right? This you replace with all. Then you will get some all sellers called Horatio. Okay. So if you do this, then you will get all the sellers called Horatio. If your rating is better than all. Okay, so like this you can do. So these are very simple things. Find the seller with highest rating. Find the seller with highest rating. So that seller who is greater than all the ratings, isn't it? Your rating must be greater than equal to all the ratings. Agree or not? Are highest rating I want. I want highest rating. So your rating must be, your rating must be greater than equal to all ratings. Correct? Agree? You want highest rating, so rating must be greater than equal to all the ratings. Then you will get the highest rating. This is the idea. Now you can implement this idea. So finally, you can find all the ratings, all ratings you can find, and then you can find those people whose rating is greater than equal to all ratings. All these things, are they simple? Tell me. Correlated query, are you finding simple? Correlated query, very simple, right? Yes or no? That meme will help you. If you want to write a query, if you want to write a correlated query, that meme will help you. If you want to analyze the correlated query, that we have seen. If you want to analyze the correlated query, for every tuple you analyze, that we have seen. So these are your nested queries. Correct? Okay. Now let's see the next. Some more points I want to discuss. This is almost the end of the chapter. Some more points I want to discuss. That can you notice this in? Look at this in. Can I write this statement? Okay, can I write this statement? So for example, can I write this is your query, like S in some R. Okay, can I write this in another way? Can I write this in another way? S in R. So I can also say that S is equal to any R, isn't it? Isn't it? S is equal to any R. So this in is same as equal to any. Yes or no? In is same as equal to any. So this in is same as equal to any. And what about this not in? What about this not in? Not in. Not in means S is not equal to all R. Okay, can I say what it will be? Like, okay, what it will be if I say S is not equal to any R. Remember, any means sum. Remember. This any means sum. So if I say S is not equal to any R, then what it means? What it means? What it means? S is not equal to any. So it means S is not equal to some R. Yes or no? There is some tuple other than R. So this will be true if and only if there is some tuple other than S in R. Yes or no? If and only if there is some tuple. There is some tuple other than R, other than S in R. Agree or not? Yes or no? See, any means some. Okay, this word will confuse you. This word will confuse you. So you put this word some. You put this word some. Instead of any, you put this word some. Now you think about it. This word is going to confuse you. Now you put this word. Now you tell me, S is not equal to some R, right? So this will be true if some tuple, if there is some tuple other than S in R, right? Correct? Yes or no? Agree or not? Is this clear to everyone? So remember, this any word is confusing. This is the very important point I want to tell you. Not. Okay. Not. Whenever you see this word any, you replace by some. Okay. In SQL. In SQL, whenever you see this keyword, both are the keywords. Both are the keywords. Both are the keywords in SQL. So whenever you see this any, you replace this with some. Is this clear? Okay. So, and what about this one? What about this? This relationship. when you have exist and you have count aggregate, this relationship, they will always satisfy. Yes or no? This will always be non-empty. This will always be non-empty. Okay, so this will always satisfy then. Then this will always satisfy. So always will you take care now? So when you see these two things together, so automatically what should come to your mind? Whenever you see these two things together, okay, whenever you see these two things together, what will come to your mind? Okay, I need to take care. Yes or no? I need to take care. So whenever you see this type of situation, then you need to take care. Correct, correct, correct. You need to take care. Just wait and take care. The same thing will happen with any aggregate function. Yes or no? Whatever aggregate function you take, whatever aggregate function you take, whatever aggregate function you take in the inner query, like this aggregate function can be anything. You can have aggregate function. Okay, you can aggregate function. So again, this will always, you should take care because this will be always non-empty. Okay, so like this relationship we have seen. Now let's move on. The last topic, that is our favorite, division operation. How can we forget about it? Yes or no? Division operation of relational algebra in SQL. This is the last topic. Once you understand this division operation in any topic, then you understand the complete topic. Let's see this last topic, division operation. Can you do it? Can we do it? Let's see this. Find the name of sellers who have reserved all the bots. Who have reserved all the bots. In the relational algebra, what you will write? In the relational algebra, what you will write? In the relational algebra, what you will write? You will write this, that from the sellers, correct? From the sellers, you will find S name SID, right? From the sellers, you will find S name SID divided by reserves. Here you will find SID on. Correct? Yes or no? Okay. So who have reserved all the bots? Sorry. Sorry. Who have reserved all the bots? Who are reserving all the bots? Okay. The bots table we need. We need the bots table. Who are reserving all the bots? Find the names of sellers who are reserving all the bots. So from the reserves table, SID, BID, SID, BID, and from the bots table, BID, from the bots table, BID. Yes or no? This will give you those SID who have booked all the bots. Correct? This will give you those SID. This will give you those SID who reserved all bots. Who reserved all bots. Then from this you can find the names. Then find names. Yes or no? Then find names. To find names, what you can do? Using some natural join you can do. Then find names using natural join. You can do the natural join with sellers and you can find the names. Correct? Yes or no? So remember, this is your relational algebra. But can we write this query in the SQL? And that is very easy. See, very easy. If you want to write a correlated query, there are two ways. See, there are two ways to write this. If you want to write a correlated query, or if you don't want to write a correlated query, but anyway, let's see this. So find the names of seller who have reserved all the bots. So from the seller table, I want, remember, from the seller table, I want names, correct? From the seller table, I want names. What I will do, this SID will set, I will send inside. Yes or no? This SID I will send inside, correct? I will send the SID inside. Inside, I will send the SID. Okay, the seller table. What the seller table will do? It will send the SID inside. So it will send the SID inside. The SID will be sent inside. Okay, and for that SID, what should happen? For that SID, what you will do? You will check which bots they did not reserve. Yes or no? You can check you can find those bots which were not reserved. Okay, like if you find, like you send SID, s.sid you send, for example, let's assume you send this SID 4. Now here you find those bots which are not reserved by 4, which are not reserved by 4. Those bots you find which are not reserved by 4, correct? Which are not reserved by SID equal to 4. Those bots you find. This, I want this to be empty or not? I want this to be empty or not? I want this to be empty or not? This should be empty. So I can put exists. I can put not exists. Yes or no? I can put not exists. Agree or not? Yes or no? Is this clear? See, step by step, I am telling you. In a very step-by-step manner, I am telling you, I want this to be empty. I want this to be empty. So I will search for not exist. So this type of bot should not exist. This type of bot. So this type of bot should not exist. So what should not exist? This type of bot. What bot? So how to find this? Those bots which are not reserved by SID, s.sid. How to find this? Those bots which are not reserved. So from all bots, if I remove reserved by SID4, yes or no? From all bots, I remove which are reserved by SID4. So very simple. What I will do, all bots you find. All bots you find, correct? So you find all bots BIDs. Minus, except you can put except. Okay, from this, what you do, you remove. From this, you remove bot ID is reserved by SID. Bot ID is reserved by SID. Isn't it? Step by step. How to find this all bot IDs? How to find this all bot IDs? That is very easy. How to find this all bot IDs? So that is very easy, right? So select bot IDs. Select bot ID, or I can say b.bot ID. So from bots. Okay. So this will give you all the bot IDs. Okay. This is going to give you all the bot IDs. Do I need to put a distinct here? Tell me, Nikhil, do I need to put distinct here? Already bot ID is a key, right? In the bots table, already BID is a primary key. In the bots table, this is already a primary key. This BID is a primary key in the bots table. This minus, what I will do? I will write those BIDs which are reserved by SID. Okay. So I want to find out those BIDs. So I want to find out, select. I want to find out those BIDs. Give me those BIDs. Okay. Which are reserved. So like r.bid. Give me those BIDs which are reserved by this SID. Yes or no? Give me those BIDs which are reserved by this. So select r.bid where? From reserves. From reserves. Where? What should happen? Where SID equal to s.sid equal to r.sid. So give me those BIDs. Yes or no? Give me those BIDs. That's it. This is your query. Should I write distinct here? Should I write distinct here? Should I write distinct here? No. Why? Why? Should I write distinct here? Should I write distinct here? Why I should not write distinct here? There is no need, because except will take care. There is no need because except will remove duplicates. You already know this will remove duplicates. You already know this will automatically remove duplicates. This itself will remove duplicates. This except, it will remove duplicates. Is this clear? Let me know, is this clear or no? So this is your query. I hope this point is clear. Anyone has any doubt? See, step by step I have explained this complete query in a very step by step manner. Please tell me, do you have any doubt? So those BIDs you can find which are reserved by SID, and you can remove from all the, okay, and basically it should not exist. There should be no such exist. So this is your query. Can I write the same query without except? Can I write the same query without except? Like without except, can I write the same query? If I don't want to use the except word, then I can write the same. Can I write the same query? So what you need to do? Okay, so what you need to do? You can send the BID inside. You can again send the BID inside. See, okay, from here you can send the BID inside. So this should not exist. What should not exist? You can find those BIDs for which there is no row of this type. See, okay, very simple. See. Now there is another way. There is another way. The same query you can write without helper, without without. Now write the same query. Write the same query without except. Without except. Okay. So write the same query without except. Okay. Write a correlated query. Write the same like write a query. Write a correlated query without except. Okay. So this is also very easy. Just think about the idea. Again, I'm going to go step by step. Again, I will go step by step. See, what I will do, I will find those BIDs which are not reserved by this for, yes or no. I will find those BIDs. I will find those BIDs which are not reserved, which are not reserved by s.sid equal to 4. Agree? Yes or no? And this should not exist. And this, for this I will put not exist. I want to find those as those BIDs I want to find. So what I need to do? What I need to do? The BIDs of bots I will send inside. The BIDs of the bots I will send inside. The BIDs of bots I will send inside, right? Those BIDs of bots. Those BIDs of bots, I will send them inside. These people I will send inside. These people I will send inside. Inside whom? These people I will send inside whom? Reserves table, right? In the reserves table I will send. In the reserves table I will send this one by one. I will send them. I will send them. Okay, ja pooch kya? Yes or no? So you can notice I will send them inside. And what I am looking for, see, those BIDs I want for which this row does not exist. This row should not exist. Which row? This row should not exist. Where? See, let's assume this BID you are taking, let's assume 103. Okay, this BID you are taking 103, one by one we are sending it. I am checking that there should not exist a row where your BID same, where this r.bid is equal to this BID, right? b.bid and this SID, and this SID has booked r.sid. Isn't it interesting? See. So I am checking the non-existence of this row. If this row does not exist, then what it means? If this row does not exist, 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 then it means that bot is not booked. Then it means that bot is not reserved. So if this row does not exist, then that bot is not reserved. Then that bot is not reserved. Not reserved by s.sid equal to 4. Okay. So this type of bot should not exist. This type of bot should not exist. Tell me the complete use of brain. Did you understand? Did you understand? Yes or no? that this type of board should not exist. This type of board should not exist, for which there is no entry in the reserve table. Array, think like this. This type of board should not exist, for which this type of board should not exist, for which there is no entry in the reserve table with that SID. Okay, is this clear? So maybe I can write the same idea. Basically, the idea is this. The idea is this. So I want those SIDs of sellers. I want those SIDs of sellers for which not exist a bot. For which not exist a bot. For which not exist a BID. Okay. For which not exist a BID. This type of BID should not be there. For which not exist a BID such that no entry, such that not exist entry, not exist record, not exist record in reserve table. In reserve table. For that bot ID, okay, with for there does not exist a record in the reserve table with S1, B1, with S1, B1 in same row. Yes or no? In record. S1, B1 in the record. Tell me, is this clear? See, very, very simple. This is the idea. If you understood this idea, you can solve the question easily. Did you understand this idea? Forget about the query. Did you understand the idea? I want those SIDs for which there is no bot, such that there is no entry. Okay, so not exist here also, not exist here also. So finally your query will be what? So not exist here. Finally your query will be what? So you will send the BIDs inside. So this is what you are going to do. You will send the BIDs inside from bots table. From bots table, you will find BIDs. You will select B.BIDs. Okay. But these BIDs you will where? Those BIDs I want those BIDs where? Now you will send them inside. Now you will send this BID inside. See, this BID you will send inside. This SID you will send inside. Okay. So you will send them to the reserve table where not exist. Okay. So you will send them to the reserve table. You will send them to the reserve table, and this attribute, this record should not exist. Yes or no? This record should not exist. So I can say not exist where not exist. I can say where not exists this type of record. Which type of record? From R select star where. So this record does not exist. Where this record does not exist, so that R.BID is equal to B.BID and R.SID is equal to S.SID. That's it. So this is your query. Isn't it interesting? Division operation is always interesting, right? In whatever, in TRC, in tuple relation calculus, in relational algebra, in SQL, there are many questions on division operation. Yes or no? Division operation is always interesting. Whatever you take tuple relation calculus, it was interesting. The logic is always interesting. So when you understand the logic of division operation in any SQL language, sorry, in any query language, when you understand the logic behind division operation, you will definitely find it very interesting. This division operation, this is really interesting if you find the logic behind that division operation. Tell me, did you get it? How many of you got it? How many of you got it? The division operation. Crystal clear? only idea you have to understood. Only idea you have to understand. Everything else will automatically happen. Okay, everything else will automatically happen. So only idea you have to understand. So you can notice this is your query. So not exist. Here you are using except. Here you are using except. So using except, you can write like this. Okay, you can write like this using except. Without except, you can put not exist here, not exist here. For every bot, you can go inside and you can do. Okay, very simple, very simple. This is your SQL. So SQL is done. So here SQL is over. Tell me, did you understand? Did you like see everything we have seen? Everything we have seen in the SQL, everything. Like I even told you what are the common mistakes. I also told you what are the common mistakes. Okay. So this is what we have done. SQL is complete. In the SQL, in the relational algebra, in all of them. So we have seen the queries. Queries is done. This queries, this is a many students, they find it very complicated topic. Okay, we have seen normalization. Normalization done. So normalization we have done. Then we have done the queries. In the queries, we have done relational algebra, TRC, SQL. See everything, the complete explanation I have given to you. When I say complete, it means from at least 10 resources, from at least 10 books, from at least 10 resources, whatever is in those resources, I have given to you. So in the SQL that we have seen, in SQL, whatever SQL we have seen, whatever relational algebra we have seen, whatever TRC we have seen, that contains the content from all the standard resources till the page 10 of the Google. Like if you search on the Google, you search SQL PDF, you will find SQL PDF on the standard PDF I'm talking about. You will find a standard PDF of SQL or relational algebra or TRC. I guarantee you that till the 10th page of the Google, you will not find something which we did not cover and which is required for the GATE exam. You can find something which is not required for the GATE exam, but whatever is required for the GATE exam, we have covered. Okay, from Raghurama Krishna, every query we have taken. Raghurama Krishna, every single query of relational algebra, every single query of TRC, every single query of SQL. Raghurama Krishna queries we have done. Like our lectures, they can be like the video explanation of Raghurama Krishna. Okay, and also some other resources like Korth, Nawate, Ulman. Ulman is another favorite book. Okay, from the Ulman. So from all the resources, the content I have taken. Some screenshots are from Ulman, some screenshots are from Raghurama Krishna, some screenshots are from Nawate. Okay, some screenshots are from Korth, and some screenshots are from the standard universities. So this is the complete SQL, complete relational algebra, complete TRC, complete normalization. So these two modules are done, and these were big modules. Now the next module will be indexing. Indexing module is not a big module. Okay, I think 3 or 4, I think 3 classes will be fine. 3 or 4 classes, maximum 4 classes, else 3 classes. Indexing is not a big. And then the transaction management. Okay, so only these two, and there is ER model that is very small. Okay, like 1 5-hour class, ER model is done. Single 5-hour class, that is also done. ER model, that is a very small topic. Okay, so from this queries, relational algebra, TRC, SQL, how many marks? From queries only. From queries, how many marks? At least 4 marks. At least, guaranteed at least 4 marks. Guaranteed at least 4 marks from queries every year. You can check whatever year you want. Check whatever year you want. 3 or 4, 3 or 4, 3 or 4. Sometimes 5 also. So from these queries, that is the reason these queries were very important, and I have covered it in a very detailed manner. If you follow our Go classes lectures, if you understand whatever we have seen, I also told you what are the common mistakes. Okay, what are the most common mistakes? What mistakes you can make here? What mistakes you can make here? So everything we have seen. Okay, so if you follow this, if you understood everything that we have seen in the lectures, if you understood everything, every example, every variation, every mistake, everything, then that is enough. You will get those 4 marks. Your 4 marks are done. Okay, is this clear? Now, this question we can solve. Before going, let's solve 3 or 4 questions only. Let's solve 3 or 4 questions. So tell me the answer for this question. 3 or 4 questions before leaving. Determine the result of this query. Determine the result of this query from scores S1 from this table. Remember, from this table, okay, this scores table, he is renaming it as S1. This is the renaming. You want team comma day. You want this in the output and you want this in the output. So these things will be in the output. Okay. And what you, first of all, is this correlated or not correlated? First of all, is this correlated or not correlated? This is simple or correlated? This is correlated, right? This is a correlated because S1.day is equal to S2.day. Okay, so what we are checking? We are checking where runs is equal to, this runs, this should be less than equal to all the runs. This should be less than equal to all the runs from scores table on the same day. On the same day, this should be less than all the runs. See, understand the query. Yes or no? See, understand the query. Forget about this. Like, you understand the query first. What this query is giving you? What this query is giving you? Basically, I want those runs. Okay, I will check one tuple at a time. Yes or no? One tuple at a time. One tuple, one by one. Tuple one by one. One tuple at a time. This is a correlated query. One tuple at a time. So when you check this one tuple, then what you will do? Okay, when you check this one tuple, then what you will do? Then this run should be less than equal to all the runs on the same day. Yes or no? This run should be less than equal to, all the runs on that day. This should be less than equal to all the runs on that day. So can you notice what this query is giving you? This query is giving you least runs every day. Agree? This query is giving you those teams which are making least amount of runs on that day. Is this clear? So what is the output of this query? Can you write in your words? So output of this query is those teams comma day. This will come in the output. Those teams comma day who scored least runs on that day. Isn't it simple, right? See, this is a correlated query, but this is so simple. This is a correlated query, but this is so simple. Yes or no? Even though this is a correlated query, but this is so simple. Think every tuple. You take a tuple and you think about it. Check it. Think. Check it. Think about it. You take every tuple and you think about it. Is this analysis clear to everyone? You know this is a correlated query. You already know this is a correlated query. So you know every tuple will happen one by one. One tuple at a time. You take one tuple and you think about it. You are getting those teams comma day who are making a score which is least on that day. On that day, that is the least score. Okay, so tell me, is this the least score on that day? On Sunday, is this the least score? Sunday. On the Sunday, is this the least score? No, this is not the least score, right? This is not the least score on that day. So this will not satisfy. I can definitely say this row will not satisfy, right? This row will not satisfy. Next, this row will not satisfy. On Sunday, who has the least score? On Sunday, who has the least score? This will not satisfy. This will not satisfy. On Sunday, the least score will be this. On Sunday, this is the least score. This is the least score. Very simple. Correct? Yes or no? Very simple. On Sunday, this is the least score. This is the least score. Okay. So now, what is the next? On Monday, who is the least score? On Monday, this has the least score, right? On Monday, this is the list score. This gone, this gone, this gone, this gone, this gone. So finally, your answer will be what? What your answer will be? Carp, Sunday will be in the result. Carp, Sunday. Next, this will be on the Sunday. Next, swallows on Monday. Okay, so all of the above. So answer will be option D. Isn't it interesting, this question? Very simple question. So correlated queries are very simple questions, very, very, very simple questions. You can very easily do. So your answer will be all of the above. Okay, all of the above will be answered. I hope you liked this question. Like, okay, this type of questions are coming in the GATE exam. This type of question they will ask you in the GATE exam. You just have to analyze. And for correlated query, how will you analyze? So how to analyze the correlated query? Analysis of correlated query. If you have correlated query, how will you analyze? Let me tell you the best method. The best method, what is that? Take a tuple. Take a tuple of outer query. Take a tuple of outer query. Is this clear? Take a tuple of outer query. Go inside inner query. Go inside inner query. Ja pooch kya? Yes or no? Okay, basically ja pooch kya. So take a tuple of outer query. Go inside inner query and check. And check when this tuple will satisfy. When this tuple T will satisfy. When tuple T will satisfy. Okay, is this clear? When this tuple T will satisfy. Check when the tuple T will satisfy and when not. Isn't it simple? Basically, take a tuple and ja pooch kya. Yes or no? Take a tuple and go and ask. So, like this you can do. You can just check it out. Okay, all these slides you can check it out. All the slides you can do that. I have full confidence on you. You can do that. All these slides are for your own reading. So this is enough for today. So tell me, anyone has any doubt? Let me know. SQL is over. We will do some practice. We will solve GATE questions. Don't worry about it. But is this clear? Whatever we have seen today.